What if a material could mimic the properties of living tissue, hold vast amounts of water, and help solve some of the planet's biggest challenges? Meet hydrogels, soft, flexible, water-rich materials that are quietly shaping the future of medicine, technology, and environmental sustainability.
A hydrogel is, you can think of it as a molecular net that likes to capture water. And it's an interesting material because it's not quite a solid and not quite a liquid, but molecules interface with it as if it's a liquid.
Hydrogels are networks of polymer chains that can absorb and retain extraordinary amounts of water, sometimes up to 99% of their weight. This gives them a unique blend of softness and strength, making them behave more like living tissue than traditional materials. In healthcare, hydrogels are making the leap from the lab bench to the human body.
Conventional hydrogels have been widely used in biomedical applications, such as scaffolds for tissue engineering, organ regeneration, and carriers for drug release.
Used in wound dressings, these materials can speed up healing by maintaining a moist, protective environment. Others are being designed to mimic soft tissues, stretching and flexing with the body in ways rigid implants never could.
So we call this a new field that we pioneered, hydrogel bioelectronics. Traditional implantable materials, such as metals, ceramics, always form this kind of scar tissues on the interface. Hydrogels, especially adhesive hydrogels, can eliminate the scar tissues.
When scar tissue forms, it can stiffen and thicken the surrounding area, reducing flexibility and disrupting the delicate structures of organs. It can also interfere with the performance of implanted devices. Because these soft biocompatible devices mimic the mechanical and physiological properties of biological tissues, they can remain in place for months or even years. Beyond medicine, hydrogels are helping to address some of the planet's most pressing resource challenges. In agriculture, they're being used to improve water retention in dry soils, reducing the need for irrigation and helping crops survive in increasingly unpredictable climates.
Farmers for more than 1,000 years, they could tell just from the coloration of the leaves that there were problems during growth. Maybe that there was insufficient watering, or maybe the fertilizer wasn't applied, or there's a bacteria or a fungus. The problem is, even today, that information gets the farmers far too late. What we're doing is we're making a whole new generation of sensors that can be interfaced to the plant and get that information within minutes, sometimes even seconds.
These sensors, made of hydrogels, gently penetrate plant tissues without triggering immune responses or stress, giving farmers a new window into crop health. And when it comes to clean water, hydrogels are also playing an important role.
So an example application that we've been really excited about is harvesting water from air. Hydrogels have been particularly interesting because when you tailor these hydrogels with salts in particular, it can actually get a lot of the water vapor, even in these very arid climates, to be attracted to this hydrogel.
These materials can absorb water at night, then release it during the day, requiring no electricity, just sunlight.
In this case, you can apply heat, and you can use a relatively low amount of energy to then release the water from this hydrogel matrix and actually get your clean drinking water. The exciting thing about hydrogels is the ability to scale these materials. Right now, we're working on these prototypes in the lab. So a really important next step is being able to take these hydrogels, being able to develop them in a way to now make tons of this type of material and integrate them effectively into now more manufacturable systems.
Researchers at MIT have played a leading role in advancing hydrogel research. Across the institute, many groups are now exploring applications ranging from self-repairing materials that capture atmospheric carbon and methane, systems that filter micropollutants from water, to hydrogels that could inspire the next generation of sustainable heating and cooling systems for the home.